All right, we're asked to consider which of the following solutions are going to produce a buffer when equal volumes are mixed. We're going to make life easy on ourselves. We'll assume we have 1 liter of each. That's going to convert these molarity values to moles. Then we consider the possible reactions that are going to occur, and then determine what's left in the beaker after those reactions occur. In this first example, we have essentially a weak acid and a strong base, hydroxide. We can predict the reaction that's going to occur because we have a strong base reacting with the acid. We're going to get the conjugate base of that acid plus water. Here are the initial amounts of each that we put in a BCA table. We see that our limiting reagent is hydroxide. All of that's going to be consumed, so we don't have any hydroxide left. We lose the same amount of our weak acid. So we have some of our weak acid left, but we've gained an equal amount of our conjugate base. So what we have in solution is a weak acid and its conjugate base. Not only do we have a buffer, but we have a balanced buffer. All right, so we think that's the answer, but for practice, let's go through the rest of the choices. Again, we have a weak acid and hydroxide, and we have 0.2 moles of each. Essentially, we are at the equivalence point of a weak acid strong base titration. Choice B is not an answer. Okay, note in the first one, we are halfway to equivalence. pH equals pKa. In the second solution, essentially we're at the equivalence point of this titration. So we'd have to do a weak base calculation to determine the actual pH. But we don't have a buffer. Choice C, essentially what we have in solution are the ammonium ions and hydroxide ions. We're also going to have sodium and chloride, but we know as chemists they're going to remain spectator ions, so we're just going to ignore them. All right, so we have a weak acid reacting with a strong base. So the base is going to pull an H plus off of the ammonium ion to form water. What's left behind is NH3. So this is a reaction that's going to occur. Let's consider what's left in the beaker when this is complete. And looking at numbers here, we see that, again, we're at the equivalence point of a weak acid plus a strong base. How the weak acid gets into solution is a little bit different. The form of the weak acid is different, but it's essentially a weak base in solution at the equivalence point, not a buffer. We simply move to the next page because we ran out of space. Let's recap. We're pretty sure that the answer is A. We've looked at B and C and eliminated them as possibilities. Let's go on to look at D. Okay, when we look at these compounds, we see they're both strong electrolytes. They're both going to dissociate completely into ions. What we have is sodium ions, chloride ions, and hydroxide ions. There's really no reaction there of interest. In choice E, we have ammonia and we have H plus ions. So these are going to react completely, all the stuff that's there, and we'll have ammonium ion or ammonia and ammonium ion in solution. So potentially, depending on the amounts of our two reagents, this could produce a buffer. Okay, so I've made the BCA table. We start with 0.1 moles of ammonia. It's all reacted. Reacts that same amount of H plus. What we have after this reaction is complete is we have 0.1 moles of H plus, 0.1 moles of ammonium ion. This combination does not make a buffer. So we've confirmed our correct choice is A.